Hey everyone, welcome back to the channel. Today I'm excited to show you an amazing CoppeliaSim library that makes testing your Arduino projects super easy, no hardware needed. Whether you're working with sensors, motors, or custom controllers, this library helps you simulate everything before deploying to real hardware. Let's jump right in. First, you'll need to download the library. It's completely free, but if you find it useful, consider supporting me via the Buy Me a Coffee link in the description. Once downloaded, just unzip the file. Inside, you'll find an Arduino folder. Copy this into your CoppeliaSim models directory, usually at C program, files Coppelia, Robotics, ye CoppeliaSim edu models. After that, launch CoppeliaSim, and you'll see the new Arduino folder in the model browser. That's it, ready to go. In this example, we'll create a project using an SG90 micro servo and the HC-SR4 ultrasonic sensor, the famous ultrasound sonar you've probably used before. Let's jump right in. The first step is simple. We just drag and drop the components we need. We'll start with the Arduino Uno controller, then add the servo motor, and finally the ultrasonic sensor. CoppeliaSim makes it super intuitive. Now here's an important detail. The ultrasonic sensor needs to be a child of the servo motor. Why? Because this way, the sensor will rotate along with the servo's movement, just like in a real-world setup. Next, we'll adjust the position of the ultrasonic sensor so it's centered and aligned properly with the servo's tip. Now that our models are in place, it's time to wire everything up to the Arduino. Just like in a real project, we need to connect our servo and ultrasonic sensor to the right pins. But here, it's all done with a few clicks. Each component in CoppeliaSim has its own GUI for configuration. Simply double-click the servo or sensor to open its settings. Now for the HC-SR04 sensor, CoppeliaSim keeps things simple. Unlike the real-world version, which needs separate trig and echo pins, here we only need one pin for distance data. We'll connect it to pin 8. For the SG90 servo, we'll set the PWM signal to pin 9. Now for the exciting part, bringing our project to life with Arduino code. Inside CoppeliaSim, we'll use Python scripting to control our servo and ultrasonic sensor. Let's break it down step by step. Under the Arduino object, you'll find two scripts, one in Lua and one in Python. For this example, we'll use the Python script. Double-click to open it, and we're ready to code. First, we'll define our variables, like the servo pin, 9, and sensor pin, 8. These match the connections we set up earlier. Inside the while loop, we'll write our main program. Here's the plan. Read the ultrasonic sensor in parallel with get ultrasound distance. Rotate the servo clockwise using the predefined myServoWrite function. Now let's tweak the code to make the servo sweep counterclockwise. Same functions, just adjusting the angle values. All right, our project is coded and running. But how do we know the ultrasonic sensor actually works? Time to put it to the test by adding obstacles. Let's create a virtual wall and see how the sensor responds. In CoppeliaSim, we can easily add obstacles using a closed-loop path. Here's how. Resize and position it in front of the ultrasonic sensor. This will act as our wall. And there you have it, a fully simulated Arduino project from wiring to coding, all in CoppeliaSim. A massive thank you to everyone watching. We pour our passion into these libraries, and your support means the world. If you try this out, tag us or comment below. We'd love to see what you create.